Now that our data is in good shape, we need to get it into the proper form to pass it into our network. With this skipgram architecture, for each word in the text, we want to define a surrounding context and grab all the words in a window around that word with size C. And when I talk about a window, I mean a window in time, so like 2 words in the past and 2 words in the future from our given input word. And more generally than 2 words in the past and future, I'm going to say we want to define a window of size C. And here I have some text from the Mikolov paper on Word2Vec. Since the more distant words are usually less related to the current word than those close to it, we give less weight to the distant words by sampling less from those words in our training examples. If we choose C equals 5, for each training word, we'll randomly select a number R in range 1 to C, and then use our words from history and our words from the future of the current word as correct labels. So this is saying that we don't want to choose too big of a window, because too big of a window will give us irrelevant context. In other words, good context words are usually the ones closest to the current word rather than farther away. And we want to include some randomness in how we define our context. If we define a context window of size C equals 5, then we'll create a range R that's going to be a random integer between 1 and 5. So say we get an R equal to 2 as an example. Then we'll define the context around a given word to be the 2 words that appear right before and after our word of interest. And I have an example here. Say we're interested in the word at the second index in this list, 741. If we randomly generate an R equal to 2, we'll be interested in the 2 tokens before and after this word. And I want you to write a function that will return context words in a list like this. This will be the function getTarget, which takes in a list of word IDs, an index of interest, and a context window size. So the effect of getting words within a random range R instead of a consistent larger range C is that you're more likely to get words that are right next to your current word, and less likely to get words that are further away from your current word. And so what you're really doing is going to be training on context words that are closer to your word of interest and likely more relevant more often. So here I've left this function for you to fill out. Now there are some special cases. If the index that's passed in is 0, or your range cannot go back in the past as far as you want, then you can start your context at the start of the passed in list of words. And you can test out your implementation in this cell below. Next, we'll use this function to actually batch the data, and so it's important that this is implemented correctly. As usual, if you're stuck or want to see my solution, check out my solution video next.